This conference will now be recorded.
Good afternoon, Soundarya.
Good afternoon, ma'am.
Tejaswini, good afternoon. Okay, let's not waste time now. I am supposed to complete this topic. So yesterday we discussed about the analytical techniques used for measuring the drug excipient interaction. What are the two techniques we learned? Suchitra? You have to find a place where you can minimize all that background noise.
Yes, ma'am.
I can hear somebody speaking so loudly. Ashita?
Ma'am, can you hear me?
Yes, dear. What are the two techniques we actually could understand yesterday to identify the drug excipient interaction?
DSC, ma'am.
Yes.
And the other one is TQ something. I forgot the name.
You should write down, no, dear. Hmm?
Yes, ma'am. Ma'am, I made the notes.
Thermogravimetric analysis method.
Parametric
Okay,
analysis. Yes,
fine.
ma'am.
You just note down, you scribble it. It's M-Form, we don't monitor like how you're maintaining your notes because now you're done with UG. I'm talking to everyone actually. So you're done with your UG. Now you're like matured enough, like you have to manage yourself. Fine. So we're just supporting you from our side. So TGA and one other one was the DSC or the thermal process. We are actually thermal analytical methods. We are trying to understand. In that one was the DSC. The second one was the TGA. So in continuation to that, we'll be learning the next analytical technique in brief. The important one was the DSC actually, which used many informations with respect to the change in the physical properties of the sample. When I say sample, the sample can be a pure API also. The sample can be the drug mixed with the that is API mixed with excipient also. So since it's an analytical technique, its application is vast. We are using it for our purpose to identify the drug excipient interactions. So whenever I say sample, it's default that it is a pure drug or the pure excipient or the drug and excipient mixture. So next one is the thermal stress testing. These are all the alternative techniques, but may not be a major one when I compare with respect to the TSC technique. So in the case of thermal stress, look at the word the stress means you are accelerating the process. So like how you do the stability study testing by accelerating condition, same here we are accelerating the aging process and that is being done in the presence of moisture or in the absence of moisture. And you're subjecting that sample to the thermal stressing. So you are going to apply, subject to the thermal stressing. That's why it is called as isothermal stress testing procedure. So one thing you have to remember is it accelerates the aging process and the interaction happens because of this accelerated condition. So, and it becomes easy for us to identify the any changes happening with respect to the drug or with respect to the combination of the drug and the excipients. So now the samples can be observed either visually, so where you can see the obvious color change. And as I told, we depend on the analytical technique. Many times we cannot identify the excipient drug interaction visually. But in case of isothermal stress testing, the one of the end point which you can use it for your purpose to say the interaction is happening or not is one is visual method. And other one is it's the combination. Visually, if you're not able to do, you need to depend on the if the no visual changes is obviously seen by the isothermal stress testing, then we have to depend with the other alternative techniques. So the DSC or the TGA or whatever possible. That's what I was telling you. One analytical technique many times may not be sufficient for us to identify the drug excipient interactions. So depending on what kind of changes it is giving us, whether it is visual or chemical changes, it is not visually possible for us to identify. We depend on the particular analytical technique. So I'm just giving you the idea what are the various methods. So this is the brief about the isothermal stress testing procedure. Points to be remembered is it is done in the presence of moisture or in the absence of the moisture, and we are accelerating the aging process by thermal stress condition, and by which what happens there is a possible visual changes which can be easily detected. Okay, if not, we have to depend on the alternative technique to identify the interaction happening. The next one is another parameters. It's not a thermal procedure exactly. It's another analytical method where we try to determine a parameter called as a solubility parameter. So it's not exactly the analytical equipment I'm talking. For example, TGA, DSC, or isothermal stress method. No, all the particular equipments are there. In case of solubility parameter is one of the parameters which you're determining to understand the interaction. So especially which it helps us to understand the incompatibility between the drug and the polymer. If at all you're using a particular polymer and any polymer is interacting with our drug API molecule, so incompatibility is the synonym term or alternative term which you can use it for the drug excipient. So they're not compatible with each other. That's when the interaction happens. And try to use the previous knowledge or try to understand with respect to previous knowledge, the interaction can be either a positive effect or a negative effect. So interaction means incompatibility, no doubt, and that interaction can be positive for us or the negative for us, means as per our need. So the incompatibility is addressed as a miscibility. See, why I'm stressing so much here about this thing is, see, when I'm planning for any particular dosage form, when I want to know the miscibility of the drug with the polymer for some reason, I want, maybe the polymer is helping the drug to undergo good solubility, okay, or to overcome the dissolution issues of the drug, where I expect the drug to miscible thoroughly with the polymer. So in this case, the miscibility is an indirect, means it's an indirect indication of incompatibility, means though there is an interaction happening, but it giving us a positive message stating that there is a good miscibility with the drug and the polymer. So this is how we are supposed to take the information out of this value, or that is incompatibility in our cases with respect to pharmaceutics is it addresses the visibility between the drug and the polymer. Okay, so better the visibility, we'll have the advantage out of it. And this interaction with no alteration in the chemical nature of the polymer or drug. So there is a chance that this interaction can be, one is you may not see any kind of major chemical changes happening. The visibility is one of the physical property happening actually. With the chemical, it is not affecting so much. So this parameter is actually explained by Hildebrand solubility parameter. Is one of the parameters. So we are not going to study in detail. It is represented by the letter delta. Solubility parameter is represented by delta. So it is a numerical value. It is one of the value which is used to estimate the interaction happening between the materials. And for our need, this is an advantage. Means we have to take the how I can use this value. See, you might be determining many values, but how I can use this value to identify the interaction happening or not. So this delta value, they are going to use it to in order to identify the interaction happening between the materials. So it is one of the good indication of the solubility, particularly for non-polar materials. So why we are depending on the non-polar? Because many of the polymers, see classification of the polymers, if you recollect, hydrophilic polymer, hydrophobic polymer, degradable, biodegradable polymers. So polymer chapter itself is the huge chapter which you can learn in detail. And we should be thankful to the polymers which is now available even as a synthetic polymers, where they are modifying other than the natural, you also have the synthetic polymers. And because of this availability of the synthetic polymers, no, so we have lot many novel technologies are coming out to overcome the drawbacks associated with the API molecules. So whenever we deal with these polymers and when we want our drug to be miscible with that polymer, the solubility parameter could be one of the parameter which helps us to understand the miscibility between the drug and the polymer. So that is given by the parameter name is called as Hildebrand solubility parameter. It's just an additional information I'm just giving you. So coming to the next in continuation, how to determine, okay, I told it's not analytical tech tool I'm talking. Solubility parameter estimation is not analytical tool. It's one of the parameter which you measure depending by the different methods. So, okay, so using physical constants such as heat of vaporization, how they calculate this solubility parameter? If at all some doubt is running your mind, okay, how to determine this delta value? So these are the there are various equations or methods by which you can determine this delta value. And some of the like you have to determine like heat of vaporization method, thermal expansion coefficient determination method, or it can be estimated directly by measurement of the solubility parameters by determining the refractive index, that is a refraction index also, indirectly using the gas chromatographic technique also. Means there are various methods by which you can determine the solubility parameter by using some of the constant values out which is generated out of some other experiment, or by the directly by using the direct measurements such as solubility in the solvents by knowing the refraction index, or by the chromatographic technique. So it's just an additional information I'm giving you. Solubility parameters, of course, we understood its importance. It helps us to understand the interaction happening with the drug and the excipient. What is generally we look, we emphasize this parameter is the interaction happening between the drug and the polymer. What interaction we expect? We expect the drug to be completely visible with the polymer, and that can be easily identified by determining the delta value. Okay, so this delta value can be estimated by various approaches. So it's not required for us to go in detail. So now as a one example to make you understand how this value can be utilized. See, this is one experiment they have carried out with the drug ibuprofen. Okay, and they wanted to select the three carriers, sucrose, maltose, and the sorbitol. So all the three carriers are hydrophilic carriers here, and I just want to know which one is best for my purpose, so that the ibuprofen is very much visible with any of this. Okay, all are visible with ibuprofen, but which one is better so that it improves ibuprofen solubility. So they determined this value, okay, Hildebrand solubility parameter value, and they got this value. This values whatever you are seeing, no, 18 point, 17 point, and 16.2. So higher the value of the, that is Hildebrand solubility parameter, greater the miscibility. This is the correlation between the value and the miscibility. So among these three, they identified that sucrose is having the higher value, and they could select the sucrose for the further study because it has a higher value of 18 compared to the rest of the two. Okay, this is how they actually carry out, means use the delta value for the purpose of selecting any particular carriers. Okay. So next method is something called as microcalorimetric method. So previous one was solubility parameter, which helps us to identify the good polymer which is visible with the particular drug based on the delta value. Same here, something method called as microcalorimetry method, which is used particularly to identify the complexing agent. Drug excipient interaction with respect to complexation in solution at a controlled temperature. So this technique is mainly used to study the excipient. That is, the excipient in this case is the complexing agent. So drug excipient interaction which is happening with respect to complexation is determined by the microcalorimetric method. So it's one of the thermodynamic parameters. Means when you want to understand the complexation happening between the drug and the carrier, so they determine the values like binding constant K and the enthalpy value, and they measure this value, they apply, they depend on some equations, and based on that they calculate that is complexation happening. So it helps in the application is, so using these values they mainly calculate the free energy of binding, that is delta G, and change in the entropy. So it is too much of chemistry aspect actually. So somehow they determine these values, so don't worry about that. But our purpose, we should understand how this can be utilized for our purpose. It is mainly used for selecting the component which has a strong tendency to form complexes with the complexing agent. So when I am talking about a carrier which is a complexing agent, I want to know how well the complex formation happens. So this complex formation is easily determined by the technique called as microcalorimetric technique. The complex formation is also an interaction, correct? It's a positive. It can be a positive interaction. Again, it can be a negative interactions. Okay. When I talk about the cyclodextrin complex with the lipophilic drug molecule, the cyclodextrin is a hydrophilic carrier. Okay, and generally it forms a complex because of its structure. So that complexing is advantageous for us because it increases the solubility of the lipophilic drug molecule. So that's how we need to try to apply this knowledge, how this microcalorimetric information helps us to identify the particular complexing agent. So, okay, so quickly, thermal process we understood, drug excipient interaction, DSC, TGA, and the next one is that is microcalorimetry method, solubility parameter method, and one more isothermal stress testing method. So these are the various methods which you can use for identifying the drug excipient interaction, and every method has its own particular applications. Okay, I cannot use microcalorimetry method to identify whether the drug is undergone crystallization or not. DSC is the best method for that. By a microcalorimetry method, I cannot determine the melting point. So DSC again is the best approach. So like this, depending on what is that we are looking at, means we have to try to use that particular analytical technique to understand the interaction happening and identify whether it's a positive interaction or a negative interaction. The next one, which is most important, and we are not discussing anymore after this. Okay, so that is called XRPD, X-ray powder diffraction. So two analytical method I want you guys to understand its importance is one is DSC. So for your M-Pharm level, I'm talking with respect to your second year project. One is the DSC, another one is the XRPD, that is X-ray powder diffraction technique. Both these techniques generally we make our students to do for their formulations during their research work to identify the interaction happening between the drug and the excipient. So I'm emphasizing more on these two techniques, XRPD and then the DSC. So this X-ray powder diffraction technique is mainly used for understanding in detail the crystalline property of the drug or the crystalline property of the excipient, whatever it may be, or crystalline property which may be disturbed because of the drug excipient interactions. So ultimately, it deals with, it mainly try to explore each and every detail of the crystalline sample. Okay, so now it is based on X-ray by crystals. Means when the light falls on any object, how it diffracts from that, the ray of diffraction. That in what angle it diffracts. I'm telling in a very simple language. May not be a very analytical technique I'm discussing. The basic principle I'm not telling. In the just in a simple language, I'm making you understand how actually they try to study. So the sample will be kept, they will be exposing that to the X-rays, and X-ray when falls on that particular sample, okay, it diffracts from the place where it falls and it diffracts in a different angles, and they capture that in the image form and they try to determine a value called as 2 theta value. Okay, and this value ranges from 44 degree to 50 degree centigrade. Not centigrade, 4 degree to 50 degree. I'm talking about the angle. Okay, so samples were packed into a sample holder and scanned over the range of 4 degree to 50 degree angle. That is measured at 2 theta angle. It's called as at a scan range of 0.5 to 0.5 degree to theta. So this is how they do. They means the value, the graph when you plot it after this experiment. The thermal graph in the DSC, now you got idea. Same in the that is gravimetric analysis also we got idea what graph we need to plot. Same with the XRPD also we need to graphically represent this is not a thermogram. Remember, this is not a thermogram. Thermogram is a word used only when you plot the graph from the thermal procedures. And XRPD is not a thermal procedure. It's one of the another different technique, that's analytical technique. So X-ray diffraction pattern is represented graphically by plotting relative intensity with the scattering angle. So it's angle, so 4 degree, 50 degree, whatever you are seeing in the numbers there, it's not the temperature, it is the angle. Okay, and that is represented graphically like this. So just taken from the internet source for your to explain to you how exactly the XRD patterns look. So the graphical representation of XRD, the other short form of X-ray powder, XRPD we call, no, powder diffraction. Sometimes you also get to see in the books like XRD, X-ray, that is powder is removed, X-ray diffraction techniques it is called as. It's one and the same. So look at this graph. This is the graphical representation of the your XRPD or XRD. So y-axis is intensity, as you can see, intensity of the peak, and the x-axis is degree. What angle they have measured the sample. So generally it is a 2 theta degree. It is called as ranging from 2 to 50. So this is how the peaks forms. So look at the peak here. Just with one example, I'm giving you. So look at this. This is the PVP. It's one of the excipient. Another one is the KT. KT is ketoprofen. It's one of the drug which they use for the study by that group of people who carried out this research work. And they blended that is ketoprofen with the PVP. So polyvinyl pyrrolidone is the PVP and KT is the ketoferron and KT plus PVP is the physical mixture. So this is how they do. They take the extracrystallography of the PVP separate, drug separate, and then they do the mixture. And what you can see as a, I'm not an analytical person. I don't know anything about them, but still I can compare, right? I can compare the graph of PVP and the graph with the KT, and then both of them together with the mixture. And I can easily see the difference. There is some changes happening. What change? Intensity of the peak is getting changed. And you have to look at the position of the peak also. If everything is fine, intensity may be reduced. Even in the DLC, I told you the intensity would have reduced for some reason, but the position of the peak will be at the same point. So the intensity of the peak you have to look at, and more than for our need, is more than the intensity, we look at the position of the peak. So position of the peak tells us there is no interaction happening. For example, this is the position of the peak. So it's the same. The peak is not disturbed even after mixing with the excipient. Okay, that's what they try to interpret. The same thing with the picture 2, you can see magnesium steel. Instead of PVP, they have done the magnesium steel, right? And similarly, they try to understand. Means you should be a person. Means interpretation is another thing which you have to be confident. And many times it's not in our hand. We cannot do. So we always depend on expert person who will be having thorough knowledge about the interpretation of the data. So we take help of those people to understand what is actually happening. By chance, if the peak is not appearing like what we are expecting, it is getting changed, then we need to really find out what may be the reason for the change in the peak. Does the crystalline properties change? Of course, see, even that can be identified. If by chance the ketoprofen drug is crystalline properties getting changed, the peak will not be at the same position. The peak position will change and the intensity of the peak will change. So that gives slight information. Look at this case in case of the second diagram. The peaks are not as well defined as in case of the pure drug. That means there is a chance of change in the property of that is crystalline property of the drug. And they try to confirm with the other techniques also as a supporting technique. Maybe they run the DSC along, subject to the DSC sample. So all together, the DSC analysis data, the extracrystallographic data, all the data they try to analyze, understand, and then they try to come to conclusion. Not with one analytical technique. Many times we may not able to get the proper, we may not get the proper information. So we have to depend on the alternative techniques. So I just covered the major techniques which are important for our purpose as pharmaceutics person I'm talking. See, like that, even we can depend on the HPLC, we can depend on the PLC, we can depend on NMR. So we are not going in detail of that. The major equipments or the major analytical technique used for For the understanding of the drug excipient interactions, I just try to cover in brief. So let me just proceed and wind up. So any doubt? Clear? So if they ask you about XRD, you should write what is XRD. Okay. And what is that they try to measure in the XRD? Fine. And how the graphical representation of XRD is represented, that also should be written. Fine. And then you should talk about what is that they try to compare. They try to compare the position of the peak, okay, or any change in the peak intensity or any change in the peak pattern also. So as I said, in case of second one, the magnesium stearate, the peak pattern is changed. You can obviously see the change happening. And that change will indicate that there is an interaction. And later on, they try to find out whether it's a positive interaction or a negative interaction. Anything you want to ask me before I just go with the next one? This is just another diagram. So look at the peaks here. If you ask me here, I really can't say anything from this graph. Means it's not a simple job for us to really tell that what is happening. Means an expert person is required always. For any analytical interpretation, we always depend on the expertise person who is actually will be dedicated to that particular analytical technique. So there's a last one, FTIR. Of course, we cannot ignore this. There's another important tool which available in our college. FTIR is maybe another one of the simple technique I should tell, which you can depend easily initially to identify the drug excipient interaction. Not only that, it also used to characterize. See those whatever techniques we are understanding. For example, DSC melting point you can identify. Same with XRD also you can identify that. May not be melting point, the peak position of that particular drug based on the crystalline structure. So it helps us to characterize the drug. I have a drug, somebody is telling this is paracetamol. So how to depend that, how to confirm that it's a paracetamol? I should authenticate that drug, right? That is the first thing which you need to do in your second year project. Authenticating the drug sample as soon as you get the drug sample to your hand. So the authenticating methods are the one which you can do it in the lab, the college level, based on the availability of facility I'm talking in our college. The one is I can carry out the normal melting point determination by your capillary method, okay, the diffusion method. The second one is I can go with the FTIR. Then I can send the sample outside where they can determine the DSC. So all this is how I can go with the UV technique. So UV method is also one of the method by which I can authenticate the sample. But make sure that the drug has the chromophore to absorb the UV light. All the samples may not have the chromophore where which you can detect by the UV spectrometric method. You should have a chromophore to absorb the UV light, and then it becomes easy for to authenticate the drug. So FTIR is another technique which you have to remember. It is called as you can short form is IR absorption spectroscopy. Okay, or there is also a modified one, upgraded one called as ATR, attenuated total reflectance technique. It's all based on the FTIR, where they try to detect the molecular vibrations, how the vibrations of the molecule. And as for my knowledge, it is mainly used to identify the particular functional groups. Mostly it is used to identify the particular functional groups which are present in your chemical structure of your sample, like OH, CH3, NH2, C double bond O, COOH. Those are the functional groups, whatever we tell now when we draw the chemical structure, that can be easily identified with FTIR, and that is basically based on the molecular vibrations. Okay, all this maybe you would have learned more detail and you remember freshly also. Maybe you'll be learning again in the analysis subject. So you are better person to have more knowledge than me. So I need to revise, and long back I had revised. So right now I'm not able to explain in detail the mechanism, but I can at least tell you at this point, you can easily identify the particular, functional groups present in your chemical structure. Even that is also one way to identify the interaction is happening. Any interaction is happening, you would be losing. Maybe that functional group is lost. So when that functional group is lost, that peak is missing in your FTIR spectra. So again, the graphical representation come into picture here. So vibration energy levels are measured between 400 to 4000 per centimeter. This is the unit what they use for measuring the range, like how in the DSC the temperature range, how in the XRD the angle range. Same here, the vibration energy range is like they try to measure from the wavelength of 400 to 4000 centimeter inverse. It's called a centimeter inverse. The wavelength is the unit used for the any spectra. Okay, so it's the wavelength. Like in case of UV, it is 200 to 400 nanometer. Okay, and 400 to 800 is the visible range, and 200 to 400 nanometer is the UV range. UV visible range is that one. Same here, the range of wavelength here for the IR spectra is 400 to 4000 centimeter inverse. Okay, it's not nanometer. So they subject the sample mixing with the potassium bromide and they plot. So one second. So I just briefly given the procedure here, what they generally do. So they mix with the potassium bromide. If it is a solid sample, they mix with the potassium bromide, triturate it, and then they subject it to the analysis. And they run the spectra from 4400 to 4000 centimeter inverse. And what they do is next they plot the graph. And this is the graph, how it looks. So same, look at the y-axis and x-axis. That's what I want my student to remember. Okay, the x-axis is wave number in this case. That is your wavelength, nothing but wave number. And the y-axis, it is the percentage transmittance. It's not visible clearly. It's percentage transmittance. And this is how you get the ups and downs of the peaks. Okay, and you can identify, means literature gives us the value. OH, for example, if the OH functional group is there, at what position the OH functional groups are identified. Is you get a ready-made values for each and every functional groups. So you can just look at that. For example, if I'm not wrong, this is the OH position. If I'm not wrong, I'm telling you, because I'm not an expert person in the IR again. But if I refer that as per knowledge, I remember this is the OH functional group. Means somewhere it comes in this range. So it helps us to confirm, okay, OH group is present. Same with CH2, CH3 and all. For every functional group, there will be specific wavelength. It will appear in the spectra. So that makes me to identify, means I need to run the IR of the pure drug, IR of the excipient, and then the IR of the drug and excipient mixture. And then the comparison. This is the normal procedure we follow. Take individual, okay, determine the individual thermogram or the spectra as in case of IR, or the XRD spectra in case of XRD, okay, and then compare it with the excipient drug mixture and confidently say that any interaction has happened or not. See, this is a very minimum thing I'm telling you guys. There's a lot of other information also can be extrapolated out of this graphs. But for our information, we are only looking at any interaction. And many times what happens, the interaction can result in a major change. So you should be, we should be carefully observing that why that if you're not finding that group, for example, after mixing the drug and excipient, if I'm not finding this group, OH group P, so I need to be cautious. I need to find out why that peak is absent. If that excipient is interacting with the OH group, functional group, chemically any changes have occurred, so IR may not give you sufficient information. So then I go with the DSC or maybe some other technique which confirms me what exactly the interaction would have happened. So this is about the IR. There's something called as ATIR. If you remember, I told you it is mean. See, there are samples can be solid samples or some samples can be liquid samples. So depending on that, the ATR is used. ATR is mainly used for liquid samples. So this ATR, and it is slightly more sensitive than the FTIR. Not only the liquid sample can be used in ATR, even the solid samples can be used. Fine, directly you can keep the sample without even blending with the potassium bromide. That's the advantage of ATR. In case of normal FTIR, we cannot go with the liquid samples. Okay, when I talk about excipient interaction, drug excipient interaction, not necessary every time your drug is and excipient are solid in nature. There is a chance that one may be solid, other may be liquid, or both may be liquid in nature. So depending on that, selection of the equipment also matter for us. Okay, just as a conclusion of this chapter, let us also understand what is the effect of interaction on the bioavailability. Ultimately, we actually want any dosage form which has been formulated should have a good bioavailability. Rate and extent of drug reaching the systemic circulation. Why we tell that rate and extent of drug reaching systemic circulation? Because if the drug reaches crossing all the barriers into systemic circulation, it can be circulated throughout the body, and it may, and that will result that the drug can reach the target site and it exhibits the therapeutic actions. So that's the reason any formulation we try to formulate, we always look at the important thing is its bioavailability. So this interaction also has effect on the bioavailability. Again, that can be a positive effect on the bioavailability or the negative effect on the bioavailability. So first example is the negative effect of the bioavailability here. Tetracycline forms complex with the calcium. This is well-known complexation which usually get to see in the books also. Maybe by this time you also understood the yellowing, the teeth turns yellow. If you are taking the tetracycline medication and you are consuming the milk, so there is a chance that tetracycline can interact with the calcium present in the milk, and that results in the change in the color of the teeth. So it's one of the drawbacks. So again, same example can be used for what purpose? So it is one of the negative aspect of the interaction. So you need to avoid this particular excipient containing this calcium carbonate. The second one is phenobarbital with PEG. So again, they have identified that there is a reduction in the bioavailability. See, I was telling you, referring literature is so important. Means I will not be using this whenever I using this PEG with the phenobarbital for some study purpose. I will not use PEG because already the literature would have quoted the drawback because of the drug excipient interaction. The other advantage, the third example, whatever you're seeing, it is with respect to the plus point, that is advantage. So danazole cyclodextrin, whenever we use cyclodextrin, remember it is mainly used for enhancing the solubility. So I told you before also, no need to worry about the drug name. You can always tell any drug in complexation with the cyclodextrin. It's always an interaction, positive interaction, because it results in the increased dissolution, and increased dissolution results in the good bioavailability. They are all interrelated to each other. So sometimes there is also a change in the functionality due to the interaction. So look at this example. Trimetrin dissolve faster when formulated with a hydrophilic filler, such as lactose. Means excipients play their role. I mean, have different functionalities. That's what in the beginning I told you. So some is used as diluent, some is used as binders. They have their own role, right? So that functionality is changed. Means the lactose, whichever is added as a diluent, that is a filler, can also add up the positive thing. Means it increases. This, for example, this trimetrin dissolves faster in the sense the added lactose has improved the solubility of the trimetrin. Okay, so means the second functionality because of the presence of the lactose. Actually, the original function of the lactose is what? To build the bulk, to increase the bulk, so that the tablet can be conveniently punched. Fine. Same with the carboxy cross caramelose sodium, CCS, cross caramelose sodium. This is a super disintegrating agent which is added up as a disintegrating agent, and mainly what happens, the addition of CCS may be an advantage when you add, because it is a super disintegrating agent. You know what is the super disintegrating agent means? Disintegration is the one of the step. Without disintegration, there is a chance that a drug will not go into dissolution stage. If at all you're talking about immediate release tablet. If it is a modified release tablet, you may not expect the disintegration to happen because, for example, controlled release, sustained release. You want this drug to be not disintegrated because the drug is released control manner or drug is released in sustained manner. There we don't want disintegration. But if you want fast dissolution to happen, I think you would have heard the fast disintegrating tablet. Generally, these tablets will have the fast disintegrating agents. So CCS, cross caramelose sodium, is one of the example of fast disintegrating agent, but they could absorb the drawback with some of the drug. So that is oxymorphone is one of the drug which resulted in the slower drug release. It's a drawback for this drug. They were planning to come out with fast disintegrating tablet of oxymorphone, but they could observe that though instead of having advantage of adding CCS as super disintegrating agent, they could see that because of the interaction, the drug release was hampered. So it's a negative effect. Okay, so these examples will make you understand means how this interaction can affect the bioavailability. So it's an indirect way of telling it is affecting bioavailability. In case of first one, trimetry, it is not actually, it is improving the bioavailability. In case of the second case, oxymorphone, it is disturbing the bioavailability because in first case solubility is increased, so bioavailability will increase. In the second case, solubility decrease or the release decrease, so bioavailability also will decrease. So there are many things which can affect the bioavailability, not only the solubility. Even the release of the drug should happen on time so that the drug can reach the systemic circulation. That's the reason we tell rate and extent. Rate means how fast the drug reaches systemic circulation. Extent, how much it reaches the systemic circulation. Both are important. For example, if the drug is reaching to systemic circulation after 3 days, no use because it may not exhibit the required therapeutic action. So, but if the drug is reaching immediately within 30 minutes, all the drug, whatever is administered, that means the rate and extent is sufficient enough to exhibit the required bioavailability. So that's how you need to understand the correlate the solubility which is disturbed due to the drug excipient interaction. So some of the other examples, this lubricant and glidant, we know that they generally added for improving the flow property. But they have noticed that with amoxicillin. So I want you guys to remember this example because I told you, you cannot understand each and every drug excipient interaction, not possible. Rule out that option. You need to write the answer with examples like this. So amoxicillin with silica, which is generally added as lubricant, other than the magnesium stearate. And already even I told you, magnesium stearate is another culprit. Depending on the percentage what we add, it can disturb the dissolution because it forms the coating around the API molecule. Okay, but within the range, if you can, if you maintain its limit within the range, its amount, then you can avoid that kind of interaction happening. So amoxicillin with silica, they could notice and resulted in the increased bioavailability. So it's a plus point in this case. In case of magnesium stearate, it was a negative. In this case, it is positive. So they could identify this positive effect. And also processing effect, I already discussed the milling, compression. You can add up this example to that. So co-ground mixture of nifedipine with the PEG 6000 and HPMC increase the bioavailability due to hydrophobic interaction between the drug and polymer. So you can add up this example. These examples are just given at last, which can be justified with respect to the effect of drug excipient interaction on the bioavailability. Okay, so this PEG 6000 and HPMC, when it was added to a particular, don't generalize. Adding PEG and adding HPMC reduces the bioavailability, so increases the bioavailability. You don't say like that. Sorry, that's the wrong justification. If you tell PEG and HPMC in the formulation, nifedipine formulation, increase the bioavailability, then it's a valid example. So don't generalize the many of the statements. So this is mainly because of the interaction between the drug and the polymer. So again, the acid-base interaction already I discussed. So can change in the microenvironment. I gave you an idea. It's something with the environment, vicinity around the drug particle. So they have observed that erythromycin acetate is converted to anhydrous erythromycin in stomach pH. So, but when interacted with sodium bicarbonate, resulted in increase in the pH and thus better absorption. Means this erythromycin acetate is generally what happens. It is converted into like anhydrous erythromycin in the acidic pH. But what happens because of the change in the pH, that is because of the presence of the sodium bicarbonate, it results in the increase in the pH because it is alkaline, and they could observe the increase in the absorption because of the enhanced solubility of erythromycin acetate. which was not possible in the presence of the acidic pH of the stomach. Okay, fine. Happy to see the last slide. So anything, this is one of the small topic in your first chapter. I was wondering, I'm taking so much time actually. Its allocated time is 10 hours. I think I already taken how many class? Completing this one of the small topic. From the day one, who was present? Tejaswini, Chandana.
Ma'am.
Yes, how many hours I took there? 5 class.
What I'm checking.
Last week 3 class. This week 2 class. So 5 class.
Ma'am. 5 class.
Okay. So what I expect from you, your side is, anyway, seminar topics I have not given to you guys. I will prepare maybe 1 or 2 days. I will list out the topic and give it to your choice. That one thing. Okay, that is something which happens later. Now, this topic, whatever we have covered, you would have already noted down the points, correct? So start preparing. Just remind me. I will share the question bank. Okay, I'll send you the possible questions. So you can start preparing your answers with respect to the possible question. Chandana or Suchitra? Suchitra,
Ma'am.
can you create a separate group of my subject? Suchitra,
Yes,
can you
ma'am.
do?
Okay, ma'am. Yes,
One
ma'am.
separate group. Only we all are there, myself and all of you, so that let us not disturb in the common group. So it becomes easy for me
Okay,
to
ma'am.
share related to the subject. So please revise.
Yes, ma'am.
So before I'm just starting with the next topic tomorrow. Sorry, day after tomorrow. That is stability. So it's all interlinked actually. You can link it. Stability is mainly affected, even can be affected by the drug excipient interaction. That's how it goes on. So any doubt?
No, ma'am.
I'm not fine. Trupti is there? Trupti, you are
Yes,
absent
ma'am.
yesterday?
Yes, ma'am. I was
Why?
absent yesterday. Ma'am, my friend's marriage, ma'am.
ಕೊರೋನಾದಲ್ಲೂ ಮ್ಯಾರೇಜಾ?
Yes, ma'am.
ಎಷ್ಟು ಕ್ರೌಡ್ ಅಲ್ಲ ಇದ್ದಿದ್ದು?
Crowd ಇರ್ಲಿಲ್ಲ ಮ್ಯಾಮ್, ಓನ್ಲಿ families ಮಾಡಿದ್ದಷ್ಟೇ. 100 members ಇದ್ರು.
Take care of all of you. Please take care of. I mean, you know what
Yes.
is the situation.
Yes, ma'am.
SK, ಸೌಂದರ್ಯ SK.
Yes, ma'am.
ಏನ್ರಿ ಸಮಾಚಾರ? ವಾಯ್ಸ್ ಇರಲ್ವಲ್ಲ ಕ್ಲಾಸಲ್ಲಿ?
Ma'am, ಮಾತಾಡ್ತೀನಲ್ಲ ma'am.
You are making the notes?
Yes, ma'am.
Ashita Verma, you have anything to say?
No,
Any
ma'am.
difficulties? Any difficulties?
No, ma'am. It's clear. I'm making notes.
Asha. Okay, fine. Asha Bista,
Yes, ma'am.
you have any problem issues? I'm talking only about
No,
my
ma'am.
class. And I don't mind
No, ma'am.
also. You are like this. You want, we want you to be like that. I'll try from my side with respect to the flow. Trupti. So Trupti is done. Tejaswini.
Yeah.
Yes, ma'am. Yes,
हाँ,
ma'am.
कैसे चल रहा है?
ठीक चल रहा है मैम, और नोट्स भी निकालना शुरू हो गए.
चलो ठीक है. Okay then, we'll see you there after tomorrow. We'll meet again with another subtopic. Fine.
Okay,
Please
ma'am.
create a group, Trupti, after by this evening, not emergency, by this evening.